So before I get started, the point of me being here today is based on, I don't know, early pandemic. I started to sort of work through, there we go, work through just the discomfort that the industry wasn't sort of moving in the way I think a lot of people thought it should. And so I started this investigation trying to figure out, okay, what could you do about it? And this is sort of part two, and I'll cover what part one is a little bit of talking about it. But really the idea and the perspective, and this is why I wanted to have a preamble, is really, it's not trying to sell you a product or anything like that. It's really just this notion that we need to change the relationship with our information, and then there will be a space and opportunity for a bunch of different products to show up. So we'll go from there. So the Road to Nowhere is it's a song. If people missed my presentation last year, I got complaints my cats didn't show up, so I brought cats back. Reese, thank you for that. I use topical cats, so if you can find the topic, we'll go from there. But fundamentally, the idea is like there's a lot of things happening, but is it leading us anywhere that's fixing real problems? And this is a fundamental way I want to look at it. So topical cat number one, this cat steals people's stuff from the yard. There you go. Okay, so part one, I was here, right there, here, talking about basically the problems that the industry experiences and fundamentally why, trying to explain why people are unhappy, not trying to explain the sort of solution yet, but really just talk through the issues. And so that's where I started. And this Road to Nowhere idea comes from the fact that I mentioned in the start of the pandemic, I started looking at maybe history a little bit, and what you sort of look at is sort of we've been doing the same things for a long, long time. So this book, 1984, the next slide you'll see stuff that we see today that people like to talk about integrating and bringing together. So this is a perfect example of, you know, little different text size and no formatting, but these are the same exercises we still do today. This book is Computers in the Architectural Office, so this is being like how computers were being used in 1984. My math is not great, but that's at least 40 years, close. Really not good at math. Adjacency diagrams, matrices, all of these things that we have to think about today that people were thinking about integrating into their tools at the time. This has happened to be something that this would now be the Populous group, but this is Wembley Stadium in 1998. The project came about, this is in 2002. You know, some things that still don't exist in like site observation apps. We had a Palm Pilot app to do these sort of things back in the day. Again, credit goes to the Populous team because this was from the sports group, but fundamentally, we had the same things we had today, just in different sort of incarnations. So the way I sort of look at this, and this is not a complete survey of anything, it's just a way of thinking about where we came from. So on the screen you see some stuff that's sort of certainly known in the UK. I work at HOK, my boss was at SOM. Each of us at the time, early in the 80s, we had our own tools. I wasn't there, I'm not that old. But fundamentally, there was a reason those tools were getting built, and my boss still today complains, why can't we do that? That was a Unix command in AES. And this is sort of the world we sort of have inherited. And sort of the thesis here is we sort of went into this world where we lost this systems view of our data. You know, it became productized, and so the data gets sliced up into little pieces, and so with that, you largely lost that connectivity between things. Just a second, I have to take some water. But in losing that, I think is sort of what got us down the path today. So realistically, the way I look at it is we've plateaued. It's a good way to think about it, because there's a lot of people doing really interesting work, trying to build new solutions, but I think there's a fundamental challenge that we need to face. Otherwise, those solutions aren't really going to be all that meaningful, I suppose, when it comes to making real change. So this was just a compilation of the stuff I had from the last presentation. The point is, top left, the graphics might be a little hard to read, but top left is, because of the way our data integrates, humans are the API connectors in our world. Every time you get a new app in your company, move data from application A to application B, and that's the person's job. We certainly have APIs. Bottom left is looking at something as simple or as complex, depending on how you look at it, like material and product information, and thinking about how it's represented in at least 13, I think, different places on that slide, and how in doing a job, it's the job of the people to make those bits of data talk together. We don't really have applications or data that talks to itself. Top right is just the notion that we can't reuse knowledge, like the idea that someone has put a door in a similar wall assembly 1,000 times over their career, but yet our applications still think that's a brand new decision every time, versus what they do today is just cut the hole. So these sort of data reuse, and then bottom right is, the hell that is moving tags and drawings. That's a lot of people's lives today. And largely the other way this manifests is, I've always struggled to come up with the best analogy, but thinking about this is very much a, sort of move data from pocket A to pocket B sort of problem. So we do a lot of work getting data out of one application, so we put it in a cart, my little animations here, I'm a fan of these, and then we just throw it down a hole into another application, which is sort of what we do ad nauseum today. And the point I said before is there's a lot of interesting stuff being done, but every time you add a new product to this world, you've just made another hole. You haven't, sort of made this easier otherwise, or you're trying to build on top of one of the existing applications. So we're left with this. Just Grumpy Cat. Unfortunately, he's passed away a couple years ago, but he's still great for quotes. Oh, that is really hard to see. If you can pick it out, that is a cat replacing a dinosaur in Jurassic Park, which is like a great feat of technical engineering in the software world, I think. So what was mentioned is, like, there are, at least, I guess it was in the title slide, but I didn't mention it. I don't think there's anything new to invent here. I think we just actually need to be much better at understanding other parts of the world that do things a little differently. And I think VFX is actually a very good example. So using the same timeline, sort of very like statistically correct graph there. Just looking at the development cycle of the sort of core tools, this is sort of the Maya's life cycle. We'll use that as the stand-in for this discussion. So they were actually behind. I mean, there's a lot of work being done in graphics, obviously, but from a tooling perspective that still exists in the market, like the AEC space was actually well ahead of it when it comes to sort of professional applications. But they've managed to keep growing where we've sort of lost everything we had. And at least forgot about it, I think, is a good way to think about it. Excuse me. So a meaningful bit of information that you learn when sort of looking at this world is, this is one interpretation, but what you find is the studio culture has bred a sort of a generational view of the technology stack they had. And so the first Toy Story timeline, everything was custom. When Maya came into the world, everybody thought it was a good idea to put everything in Maya. They quickly found that that's not a good idea because of the problems we see in our industry today. And at the same time, Maya is pretty extensible, so they started building on top of it. That's sort of generation 3, and this is the actual place I'm going to talk about copying. And then generation 4 is what they're actually seeing today, which is this really maturing view of the world that is on top of USD. And I will not try to explain the intricacies of USD today, but it's the sort of the external representation of the world. So USD stands for Universal Scene Description. So you can put those words together and generally come up with what it means. But that's the world they're living in today. And from my perspective, we need to copy number 3 as a starting point. It's, take our tools, don't try to replace them, externalize the data. So if you look at how they got there, this is Pixar's version of this. Just as we're plateauing, 1998, Marionette, I will not try to describe any of these tools for you, but this was a journey. It wasn't a sort of, oh, we solved it immediately problem. So it took them 4 steps, and it roughly maps to the sort of versions of the world, but it's not actually the case. And just from a timeline perspective, USD started to be developed 10 years ago at this point. But it's sort of the thing that's actually got them sort of up the hill, if you will. So if you compare that view to what we have today, which is sort of these sort of pocket A, pocket B, or throw down a hole, they realized over those steps that what you should be doing is sort of, instead of letting the data live in these applications, you sort of make them editors. So you externalize the data, you sort of move data in and out of them, because tools are really good for these sort of things. And what you're left with is actually, at the end of the day, USD, so that's why it's called Universal Scene Description. It has everything in it that you need to sort of represent your scene. There's application-specific stuff that might not be in there, but really what you're left with is a full view of the world that you can address in a whole bunch of ways. So I like to use this as an example because it really points to, at least from my perspective, we should not be trying to replace one tool for another or anything like that. We should try to make the market work for us. And to me, it's a really good study of how that market has changed since this has happened. So USD comes along. All the work from NVIDIA that's happened recently on Omniverse is based on this sort of technology. There's work from Unreal and Epic Games. But then just this pipeline of technologies that sort of come out around it, because any application can talk to this data set. It doesn't have to use, there's APIs, but you're not talking to an application interface, you're talking to a data interface. So you can build different tools that talk to it. So in Pixar's world, we have RenderMan, Material X comes, whoa, that is not what I wanted to do. Sorry. Big fat thumbs. Material X comes out of ILM. Then you have an open community that's started to come together called ASWF, Academy Software Foundation, that started to build all kinds of other standards that you could start to build equivalent things. I think the meaningful one is like thinking about open timeline. You can imagine a timeline of when rendered effects, cues, all these things happen across projects. Like a timeline in our industry is not a shareable thing from a construction sequencing and so forth. So these are very equivalent ideas that sort of come up from here. So this is actually what happens when the market has made this shift. And if you poke around on YouTube, you'll actually find like much better examples of like that. I just wanted to show you a YouTube video, but like actually the Maya team showing how USD works really well in their environment. And I think it's clear to say from like no matter what AEC company you're talking to, no one is trying to sell you on the idea that don't use our format, use this standard one. That's not something you hear often in our industry, and I think it's really meaningful to understand it that way. So how do we actually replicate something like this? Again, this is not new ideas. This is just copying from other markets, trying to stitch something together that looks sort of meaningful for us. So pretty straightforward. You start with a bridge. We don't have anything like USD, so we have to start with what we have. And to me, that actually is starting with a one-way connection. And if you do that, you have to make some both choices, but you have to start to really understand, well, what could I do with a one-way connection, or what would I need to make it useful? And this is when you start to sort of quickly sort of figure out what are the steps we need to start to climb this mountain, and I'll really walk through them. But the keys here are externalizing the data, and then essentially just like if you put some money over there, it wouldn't be useful. You need a way to leverage it, spend it. So if we're getting this data out, we have to make tools that take advantage of it and start there. So I always like thinking names first. So this is where I started. Magnetars are neutron stars that are most magnetic. So it's if you have a supernova and it doesn't become a black hole, this is the magnetic thing. So blow it up and bring it back together is a good analogy for a magnetar. So that's why it's my name for this stuff. It has no meaning whatsoever, but I just like to share that it's I have a nerdy name for this stuff if you want it. So business cat, I don't think you can sell this idea without actually starting proving it. So I've sort of started to build prototypes to prove out this idea. So the first thing you need to do is manage change. So if you think about it, if I want to sort of have somebody trust some information over here, and thank you for the lav, because I can move away from here. If you want somebody to trust information that's external to the tools, you have to have really good change management. And we don't have that at all in AEC, but it's actually, there are places that you can at least demo it. So in a proof of concept, let's say that number 1 disappears to the bottom. I need to be able to reflect that at the top. Very basic idea, but it's pretty important. So where I started was, well, can we build a piece of technology that proves this idea? So we'll get this to play here. So very basic. This is on top of Revit, but it's not meant to be anything specific to Revit. So a new item, a modified item, and a deleted item. You save. There's tooling that companies like Autodesk and others are making to manage change that this is taking advantage of, so it's not inventing anything. But basically what I'm doing then is streaming that out to a little database that sits next to it and say, oh, I have some modifications, I have some new items, I have some changes. That's a good thing. I could do it. This is a demo of a very small change. The capabilities are there to do this within seconds with gigs of model data at this point. This is just an early proof of concept. So this is the second prototype. Today it's a little SQLite database that sits next to the file, but clearly there's a direction that if you put this in the sort of a cloud infrastructure, you could do this across sessions and you'd have change data across everybody working on a project. So if you remember back to the VFX sort of Gen 3, it was both externalize and extend. Okay, so the first place I go to is, well, how could you use this data in the native environments to help people doing real work? How could you use that data to make their lives better? So by extending that information, what you could do is actually overlay change data back into the tools. And if you're smart about it, you grab deletions and you know where deletions were. So you keep that history, and so you can say, oh, 2 weeks ago, this was here. Very simple stuff, but just from a practical perspective, you can, leverage that data to make someone's lives easier. And the very basic example is, we cloud drawings incessantly, it seems. Use that data to help people cloud drawings where the changes are. It's not perfect, it's a good idea. This, I will say, is not a prototype, this is just a mock-up. The change management and the IFC export are real things. This is just how you'd use that information. So next is leveraging that data from a change perspective. And change perspective when it comes to other people's data. So if you think about it, in this scenario, I'm an architect. It does say architect, right? Structural slab edges is what it says in the upper left. So just walk me around all the elements and help me coordinate them. Well, this is sort of one of these things that you could do this continuously every time you issue the data, but it's what is really interesting to understand, and I certainly did not understand this until I tried it and thought about it, is if you actually have a good record of change, you can know what didn't change. And so that means you could, before you issue some information and instead of having to spend hours looking at everything, only look at the 4 of 50 things that actually changed since the last time you looked at it. You could expand on this idea to make it much richer, but I think it's quite interesting to realize how much time we look at everything because we don't know what to look at, which is the opposite of change, right? But it's a problem we don't address, and I think it's a meaningful outcome that we could really sort of get to if we embrace these ideas. grab some water again. Okay, so if I know the change happened, I need to get the data somewhere that I can use it. So you have to give yourself some meaningful rules. It has to be close to automatically. That doesn't make sense. Automatic. Minutes, not hours. And reliable. And this is fundamentally the thing. You need to be able to rely on that data. I can't know or can't not know that I don't have everything, which is a sort of fundamental idea. So if you think about in this file perspective, what you're really going to struggle with is just this is going to take forever. And this is the world we have today. So you sort of really can't think about it from a file view. You have to think about it as an element approach. And so if I just think about elements, then you could say, well, just give me the few things that have changed. So same thing, prototype, take the existing exporter and make a by element exporter, just a bunch of files. The reason I think this is doable is because if you look at like a game engine, game engines could have close to millions of little files on disk, and they're really fast these days. We don't have great representations, but I think we have the license to at least give it a try because this approach works with fast SSDs and object storage and so forth. And then if you marry that together with I know what changed, the only thing you have to export is changes. So top 3 things as we demoed in that previous thing. It's a very simple recipe, but we have not done this today because we sort of generally think in files. Logical question is, okay, we get this data out, how do we use it? I mean, must ask you a question is a pretty good pun, right? So first thing I think we should do is leverage what's happening in the open source world that's really exploding, which is basically IFC viewers and specifically IFC.js on top of 3.js. Start there with the premise that if you put this data together in a viewer and can assemble it, then you can make some sort of interesting tools. So this is just a mock-up, nothing real here. If this is an assembly of elements versus a single file, I'll talk about how we get there in a second. And I put that next to some versioned external data. All of a sudden, I'm in a position of being able to use model data external to the applications, and I can version control that. Version control it in a way that I actually can easily catch up in the future versus what a lot of these processes that look like this today are actually, you throw it away and start again. Or give me a new export because I don't possibly know what changed in your data set. And interestingly enough, you could, because you know the changes and you know when you're out of date from the applications, you could actually think about putting that data back in. So what does that mean? So functionally, it's many different apps, many different users making small different tools that can leverage that data. But like just the list of laborious, stupid stuff that we deal with that we can't use models very well, like that's my list. But there's so many of these little things that you could come up with that are customized. And again, it's a simple model. It proves an idea. It's not like you should think you're going to buy one of these things tomorrow. I think it's really just the model of versioned element model data plus some external information. What could you do with that again? This is an example from a healthcare project. Project architect had to classify all the elements across a bunch of spaces and corridors just to help the team understand smoke fire partitions, construction types, and so forth. To me, this is a perfect example, like why give someone a sort of 300 megabyte file versus a really lightweight web experience that can bring all the data together in one spot, make these decisions, and push the sort of valid metadata back to the authoring tools. So the way I do these, just in case you ask, I literally search these 2 words, and this is the sort of stuff you get. This cat, actually, you plug in an audio device. This cat is no longer available, sadly. It dances to it. So we're missing out. I think the world is a poorer place. So I'm going to click this, see if it comes up. There we go. So we have the data external, but that's not the way we generally deal with it. So we have to start of steal from the mechanical space and start of thinking about maybe an assembly concept. This is not that at all, but it's really, can I take this small bit of data, and the fact that I'm using IFC really helps here, is IFC is super flexible, and it's got a lot of data representation properties that a lot of the other formats don't have. So as a starting point, I'm gonna have to find the control here. Oh, it's on the other screen, there we go. So what's happening here is, first we're going to export. You don't have to watch these steps, and you get all these little files on disk. This is just like, imagine the first export, version 1. Hundreds of files. You bring them together, actually near 500 files. Bring them together into a merged state. So you make a few changes. You get the idea here. And instead of exporting everything anew, you only export the differences, right? So a few things. Revit is chatty. Revit changes a lot of things, so you get a lot of those there. So we get the updates. So this is some work that's going to be open sourced by the team at Quantic that actually merges this. If you search for owner ID, there's this concept that shows you, well, those elements are part of that owned transaction, if you want to call it, and then the other elements are this newest one, 17 items. So what you're actually able to start to do is assemble a sort of representation. And then last example here is, okay, make some deletions. The simplest way is just to tell the file it's been deleted. And then lastly, you sort of merge this all together. And so what you see here is 3 transactions just that have come together from this merging process by just doing changes. I don't know why that toilet's floating in space. I'm sure that's my fault from doing a demo incorrectly. But yeah, the meaningful thing to kick out of this is that there's actually real history here, which is we have none of this in the actual way we work today. We can compare versions of models, but you could never get transaction level data from the work we do today. So I need to get back here and catch up. So really this is sort of thinking about how we use this concept as we look ahead, because if we literally want to get to delivering models, not drawings, but we want drawings as well, we sort of have to think about how this helps us. So I like to think about this as assembly of information. So you take the pieces, put them together. Oh, here's this package of information. You could actually clump it together. So here's the meaningful stuff. Here's the reference like we do today. But if you think ahead and play this forward, this is closer to an assembly. You can clean that data. You can sort of use machine intelligence to automate, work around it, checking it. But it's a much smaller data set than check everything. It's just, no, this is the meaningful stuff, take these pieces. And then, you know, if you have another package, you get some updates from the previous one and you put those together with the data you have. It's such a simple concept that it's dumbfounding that we don't do it today. But you know why? Because we sort of have tools that think in models. So this is a trackable, auditable, checkable process. And then from there, you think about, well, almost every tool we use can author data this way. I just did an example of using it one way. Again, it's proof of concept. It's not that you can do this today in every tool, but I think fundamentally it's something we should aim at and understand that's possible. And then finally, I'm of the view that drawings need to be free, which is to say that like you do all this work in the model, we shouldn't have to spend a lot of time on it. So is there a good example, and this is again, stealing examples from other people, of doing something like that on an open data set? So this is a Korean tool. This is actually built by a consortium. I'll go quick with this. Hit play. So what happens here is this is just one IFC file loaded in. Everything you see on the right is a drawing, a view, you could call it that as well, of a model generated from IFC data. Again, it's a proof of something existing that does this, and this model was actually assembled the way through the merge process I showed before. Again, this is not a commercial tool. It's freely available to test and use, but there's proof in the market of these sort of pieces sort of coming together. And drawing should be, everything. I'm not talking specifically about a specific kind of drawing sort of approach. So lastly, taking whatever others have built, we should then extend this idea and make platforms for this information to come together, merge it together, use viewers that are standard across the industry. I'm running out of time here, so I won't go to this next one. But this is just an example of the IFC.js tools, and I'm sure I'll be able to share links at some point if you're interested, of somebody just making a housing plan viewer. So where does this lead? That's fundamentally the question here. Well, this is obviously just a start, and it's a glimpse of a solution. None of this is available today in a way that you could put into production, but all of the tools that I'm building and the work the people I'm working with is meant to be open source, that you can use it for anything. So these experiments will be open source. It's not meant to be closed. But I'm of the mind that just like what's happened in the other markets, we're going to have to do this ourselves. And by ourselves, I mean the players in the industry, not necessarily architecture firms or engineering firms, but people that use the data, work on the data every day are going to have to do it ourselves to make this standard approach come about. Not the tools. We shouldn't want to have to build everything ourselves. So just to make sure everybody's clear, if you walk away, USD doesn't solve this problem because it's just another file. There's some really interesting stuff, just like the owner history stuff I was showing in IFC that makes that collaboration really happen. We have to figure out how to do that ourselves as well. We can take IFC and expand it. There's other formats, but we don't have that work today. We need to steal stuff from others as well. I mentioned the gaming world has not embraced the cloud-first approach when it comes to sort of AAA gaming, which a lot of our projects are bigger data sets than that world. So it doesn't mean we should shy away from a technology, but we shouldn't automatically decide we have to use one technology because of that. And then finally, we have to work together. So I mentioned this started at the beginning of the pandemic. Over the last few months, I've started to put this pitch in front of firms that I've been talking to for some time with the whole point of, okay, this is a good idea. Let's figure out how to flesh it out and build from there. So finally, future cats. Oddly, you get two examples of saving the future via cat, which I don't understand. So Doctor Strange protecting the future and Back to the Future in cat form. So I think it's actually very good and apropos that really what we're doing is sort of protecting ourselves by doing this work and planning it today. Thanks.
Hi. So some of the things I want to point out there is that talking with Greg is the important thing is the atomization of models. So you have a model, you atomize it, you stick it in a data lake, and then you can start to do stuff with it. And the Connect guys are here. They've come from Ghent today. This is the first time that I've actually ever shown what I call fresh code. I think you guys delivered this about a week ago. So this is really hot stuff. This hasn't been seen before. So anyone got any questions? Otherwise, I'll dive in. But anyone's got any specific questions about what Greg is doing? Oh, sorry. I'll run around.
Hi, I'm Andy from, I'm a Rhino developer. I work at Robert McNeil & Associates. I didn't quite get this clear. Are you advocating specifically for USD or?
No, I'm very much just saying that it's a pattern we should copy, externalize the data from the native applications. And my experiments are really using IFC because that's the only thing we have, but I think we need a much more richer representation eventually. In summary.
Do you have any idea what that looks like? I
can give you traits, but there's no good, the candidates, just to be, the candidates I've looked at are what Bentley's doing with iModel is interesting, but not yet open. IFC, and there's some interesting stuff happening, but I think the change detection at the element level and version history is the biggest one, and there's not really that many out there that do that. So unfortunately a short list.
Cheers, thanks.
And the interesting thing is that if you've atomized your data and your data is an IFC data lake, then the RVT file or whatever proprietary format you're using is no longer super useful, because you've actually externalized the data for a lot of the things that you might send someone an RVT file for. And then if it's IFC, the thing that's great that's happening in the industry is IFC was bad because it was a written documentation which everybody wrote to interpret themselves. So we ended up with really crap IFCs talking to really crap IFC readers, and it was a nightmare. Now pretty much everybody, including Autodesk, are using the ODA libraries. So you've got standardization of IFCs. So we've got go on.
Well, I was going to say in my third job, I'm a volunteer as one of the co-technical directors in Building Smart, and we know it needs to be modernized to support that stuff. So we have a meeting actually next week to start to talk about all of this stuff, from representation to encoding to serialization, across the web on disk, and all these things are on the table about what needs to happen in the future.
And in my head, the thing that's super cool is that, HOK might have 20 Revit users and they might be using a data lake, but they can all share information between each other using the data lake and get that componentization stuff and not have a dumb file. Similarly, because it's IFC, you could have an ArchiCAD user, a Vectorworks user, a Revit user, a BricsCAD user, a Conic user, and the IFCs will flow between these products. And it's almost as if, in my head, and you'll probably say, I'm getting too far, I'm getting too far, but it's almost as if HTML is the IFC, and your authoring tool almost becomes the web browser, which is a little bit more exchangeable than we are today. I know there's no way you could throw out all your training and swap to something else, but the possibilities of having this, or having this capability, and it not being owned by a software vendor that's trying to feed shareholders, is an interesting thing for this industry, because suddenly you're in control, and you also have open formats, and there's everything that Greg's been doing and we're talking has to be open. So everything's being built by open components, and the thing that this industry needs is more openness, and it's amazing it's come from HOK.
Right, but I guess the big problem is fragmentation of the standard.
Oh, absolutely. Again, Martin uses IFC, and I think IFC can prove itself in a proof of concept. It is not what we need something, an evolution of whatever we're talking about to really make this practicable. Again, I'm proving the idea, not saying that this is exactly what the solution looks like. And I think that's an important aspect of it.
I mean, I totally agree with you. The trouble is, I just don't see, what I see is IFC was one attempt to get there, an outdated one,
I'm very much advocating that we need to, somebody has to put the work in, and it's only going to happen if we put the work in versus asking the software companies to do it.
To some degree, the trouble is defining who we is. Because if it's a big group of people, then you get a fragmented standard. If it's a small group of people, like in the case of Pixar, where you have essentially a monolithic industry, then you basically get to define it yourself.
No, there's a lot, don't get me wrong, there are a lot of challenges, but I don't see any other thing to copy. Let's say it that way.
That's fair.